Good morning everybody, myself Acharya Vishvendra, and today I'm going to discuss a worksheet on magnetic field. So first is dimension of magnetic field. So magnetic field has the dimension m1 L0, t minus 2 I minus 1. The next question is SI unit of magnetic field, so it is Tesla or Weber per meter square. Then is CGS unit of magnetic field, so it is Dian by SU and second by meter. Then its magnetic field is so it's a vector quantity. Then we are being asked about elemental magnetic field. So magnetic field due to a current element is given by mu naught upon 4 pi I dl cross r divided by r cube. So the concept here is, suppose this is the current element IDL, and due to this element we have to find the magnetic field at point P, whose position vector with respect to the current element is vector r. So this is the expression for elemental magnetic field at this point P. Then we have another question, that conditions for which dB is 0. So the conditions are, as we can see from here, either I is 0, dl cross r is 0, or r tends to infinity. So dl cross r will be 0 when either theta is 0 or theta is 180 degree, or a combination of these. So these are conditions for zero magnetic field. Next we have conditions for magnetic field. So obviously cross product is maximum when the vectors are perpendicular. So the current element and the position vector P have to be perpendicular for getting maximum magnetic field. Then we have minimum magnitude of magnetic field. So that will be minimum when angle is 0 or 180. Just like this. Suppose the current element is along x-axis as shown over here. So both at point 1 and 2 the magnetic field will be 0. Next question is, we need to find magnetic field that's in various configuration. The first we have is a complete circle in which current is flowing clockwise. So magnetic field will be down the plane from over here, and its magnitude will be mu naught I by 2r. Then we have the same question in anti-clockwise sense. So magnitude will remain same, but here direction of magnetic field will be up the plane. Then we have semicircle, so magnetic field will be mu naught I by 4r, and it will be inward down the plane. Then we have anti-clockwise, so that will be mu naught by 4r up the plane. Then we have a combination of two straight lines and one semicircular arc. So the magnetic field due to the straight segments will be 0 at C, because in one case theta will be 0, in another theta will be 180. So as I have discussed, magnetic field due to these two will be 0, and it will be the net due to this field, and it will be obviously down the plane, so represented by cross. Then we have like this. So same concept can be applied over here. Magnetic field due to this straight segment will be 0, due to this also it will be 0, and there will magnetic field due to the semicircular part, which will be mu naught up by 4r into that is represented by dot, which means magnetic field is up the plane. Then we have the case of infinite wire. So the magnetic field here will be mu naught I by 2 pi r, and it will be down the plane, that's why the symbol cross. Then we have another case, but here same magnitude will be there, but it will be up the plane. Then we have a case of 3 wires. One is semi-infinite, another is also semi-infinite, and this one is a semicircular. So magnetic field will be added due to all of this. So these two will make magnetic field mu naught I by 2 pi r, and this one will make mu naught I by 4r, and direction will be up the plane. So that will be the direction of magnetic field.